So welcome everybody. Hope you can hear us. So welcome to my next session, which is the second part of domain interoperability and ontology harmonization. And so I will be moderating this session where we have 3 speakers. So then we have an interactive part where we will actually ask you to come closer so that it's easier to ask questions and so on. And without further delays, I would like to, it's always my pleasure to invite Øystein Linebo, who is a professor in the Department of Philosophy here in Oslo, to give the first presentation. But maybe, can we just briefly, okay. The agenda. Just briefly, just as a reminder, sorry, I forgot. Maybe it's a good idea just for everybody. Can we? So this is what we have now in this session. So we have the first talk now, then there will be 2 brief talks by Alberto and Ilaria. And then, as I said, time for questions and interactive slot where we will ask you to really participate. So thank you, Øystein. Please, floor is yours. Only when you have 2 minutes left.
Okay, good, thank you. Right, welcome. So I will speak about something we call core constructional ontology. And let me begin by just describing to you the context of this work. So in 2017, there was a report in the UK called Data for the Public Good, the one you see a picture of here, recommending the creation of a UK national digital twin. So the idea here was to bring together all kinds of individual digital twins into a kind of system of systems with which then has this vast representation of national assets. And of course, this has very high demands on interoperability. So to achieve that kind of interoperability, we need to have the appropriate foundations. That was very important. And this is where the work that I will describe comes in. We worked on the foundations, and that's where the core constructional ontology comes in. So here's a representation of the data layers of the associated information management framework. So on top, there's a dynamic data layer, then a reference data layer, and we are interested in the foundational data layer. And not only that, but really the rock bottom of that. So here, as you see, there's a foundational data model, which then rests on the top level ontology, which was chosen to be 4-dimensional and extensional. And all of that underpinned by what we call core constructional ontology. The idea being to kind of have a unified way of dealing with some entities that come up in many of these top-level ontologies. And the inspiration here comes from work by Kit Fine, a so-called constructional approach, where you construct the entities that you require. So here's a little bit about constructional approaches and what we mean by that. So the basic idea is that you start with some givens, objects that are just given to you from the outside, as it were. Then you have constructors, so operations that you can apply to the givens so as to produce constructed objects. And often you could produce these objects in different ways. There may be choice here. We will see some examples of that as we go along. And continuing then with the constructional approach in general, the types of objects you get, they will be determined by the kinds of constructors that you use. So you have, say, a set constructor, which will produce objects of the type set, and so on for other kinds of constructors. And the identity of the constructed objects will be dictated by the constructors and whatever you apply the constructors to, so what you feed into the constructors. So that's constructional approaches in general. Now a little bit about what we did, so our approach here. And the givens for us are mereological atoms, so objects given from the outside with no part-whole structure. And the constructors we're interested in are these three, most of all. So set constructor, sum constructor for merological sums, and then pair constructors. And with pairs, of course, tuples quite in general. And then you have this kind of interaction between the constructors and the constructed objects. So the constructors give you constructed objects, which you can then feed into the constructors. So you also go from these objects into further construction, and you kind of loop around in that way, generating larger and larger ontologies. So here's an example that will be familiar to some of you, the construction of sets. So this is a case that received quite a lot of attention in the logical and philosophical literature, where we have a vast process, figuratively speaking, of constructing sets. So you have stages, which are linearly ordered, and not just that, they're in fact well ordered. So the stages could be these. We then hypothesize that the stages could extend into the transfinite too. And then along these stages, you construct sets. So at any stage, you have some objects available, the ones you have constructed by that stage. And then you could feed those objects into the set constructors so as to construct more sets. So one example here would be, say, having the singleton set of the empty set at stage 1, which you could use to construct its singleton in turn at stage 2. So that's how it goes. Of course, for applied purposes, we need givens. So you're not going to start with nothing, as on the previous slide. Rather, you will start with the givens. So this gives you a fatter hierarchy of sets that are constructed from the bottom up. And we generalize. So we want to construct parts, sets, tuples, really alongside one another, and in that way get a unified account. That's one way in which we generalize. Another way is that we want a more flexible construction process. So maybe you need first of all merological sums, and only later you need sets. So then you first construct the sums, then the sets, or some sets as you need them, or in whichever way you please, really. And third generalization is that we need so-called traces. So these are special objects that kind of log the structure of the construction process. So by which process did you construct this or that object? So three key aspects then of this account. It's foundational, it's unifying, and it's constructional. So I'll say a little bit about each, and here I'm going to be very, very brief. So fasten your seatbelts. Foundational, object completeness. So all the objects you need are constructed. They all come out of the object factory, as it were, except the givens. Categorical completeness, so the categories of types you have, of objects you have, they all result from the constructors. So that's nice. Identity criteria, all these objects are given identity criteria by the way in which they were constructed. Continuing, it's unifying in various respects. So these kinds of objects, sets, sums, tuples, which are ordinarily treated one by one, are now constructed alongside one another. And that's nice. It's more unifying. And you have a common basis for identity criteria and a uniform way of capturing commonalities and differences. And it's constructional, of course. So dependency relations come in here. Some objects are built, as it were, from other objects, and in that way depend in some way or other on the objects from which they are built. And there's a kind of reduction. So you start with a given, everything else is constructed. So there, you can think of the constructed stuff as reducing to the givens. And by constructing everything, you have a very good mathematical understanding of what is going on, which allows us to give a proof of consistency. So here's an example involving merological sums. So we start with three givens, the three colored blocks. Then at stage 1, you form all the merological sums that you can form from those. So at stage 2, you notice you get nothing new. The construction terminates at stage 1 already. Kind of. But when it comes to the traces, it's a little bit more complicated. So the traces are records of how things were constructed. And you see here that this triple, which can be constructed from 3 of the symbols, can also be constructed using one of the objects that enter only at stage 1 as a building block. So the trace to that effect comes in only at stage 2. Okay, so a little bit about the theory and the logical framework that we use. So we use the so-called plural logic, where ordinary first-order logic has just singular resources. We also talk about many objects simultaneously, namely the things from which you construct. So we use these double variables to have many values simultaneously. Plural quantification, it's called. So the primitive notions that we have, there's logic, there are the constructors, and then the construction process. So we need some primitive notions for that, for stages and so on. And to give you just a flavor very quickly of the axioms, they come in different groups. So some axioms are concerned with the plural logic that we use, others with the structure of the stages. We say there's an initial stage, there's stuff about what exists at a stage, and then of course axioms governing the individual constructors, and axioms governing the traces and so on. So quite a few axioms, but they break into two pretty natural groups. And then some of the payoffs. So you get very natural definitions now of being an element of a set. That's simply to be one of the objects from which that set was constructed. Being a mere logical part of, that's to figure as input to a construction, resulting in that sum. And on that basis, and using the mentioned axioms, we can now derive all the axioms of standard Zermelo-Fraenkel set theory and atomistic general extensional mereology. So some final remarks in wrapping up here. This resulted in a technical report, which you see a picture of here, which does all of this properly, including a proper proof of consistency. Here are the authors, including 2 other people present in this room, Chris Barters and Stefano Borgo, contributing. And then lastly, some ideas about extending. So I mentioned the Finian pedigree of this, and this uses just some of the Finian resources from Kit Fine. So it would be nice to harness all of these resources and perhaps beyond. And I am also in connection with an ERC project I'm just starting on, also interested in constructing objects that are intentionally individuated. So groups, collectives, social entities, perhaps. So thank you very much.
Thanks a lot, Austin. Fascinating talk. Are there questions from the audience? Yes, please, Barry. I think.
So just a quick test question. How would you account for the part-whole relations between the cells in your body and you?
Well, that's a good one. So it depends on what the givens are. So if you're artificially building my body, then the givens would be the cells which are assembled to construct my body. So that would be the way to go.
Yeah, so
there is a different way. One could extend the framework so as to make me the given. And then you kind of take me apart to obtain the cells. That's not part of what we do here, but that's a natural extension which could be done.
So it seems that you're using temporal expressions in terms of the history of construction to describe temporal relations which take place in the real world, which isn't constructed. It's the whole real world is, if you like, I don't like the terminology, a given. But you can't have your cake and eat it. You can't describe the history of reality in temporal terms, in terms of a use of temporal order, phases and so forth. which
yeah.
just captures the construction.
Yeah, that's a good one too. So the temporal terminology is just so powerful here and so useful to have. So we talk about construction and the process and coming before and after. But when we talk about sets, for instance, it's not, these are abstract objects. They aren't literally brought into the world by us, I would say. We construct literally representations of the sets, but the temporal imagery is still being used. So one needs to, in any kind of stage theory or constructional approach here, you need to be willing to indulge in that kind of temporal imagery for heuristic purposes. But one shouldn't.
To indulge you.
So would you like to, please, Stefano, I see there is another raised hand. Please, Stefano.
Thank you. It's very nice. As you know, I like very much the approach. But still, I always wonder, how do you manage to make sense of reality per se, where, for instance, we have intentional agents, and it's hard to explain intentionality as a construction of something. So as you assuming that some of these givens are, no, I don't know, some intentionality given, or some, how does it come out that we can explain everything of the complexity?
I think this is connected to some of the extensions I mentioned on the very last slide as things I wanted to do. So yeah, the objects constructed in core constructional ontology, they're very extensional. So sets, super extensional, merological sums, thought of in a very extensional way again. So it would be good to extend them to other kinds of objects, intentional objects. So I'm all in favor of that, but that's not part of what we have done in the work I reported on here. That would be the next chapter. Yeah.
Thanks a lot. Are there any questions online? No. So thanks a lot, Øystein.
Okay.
So I will ask you to stay with us for the following part. So now I would like to invite Alberto Olivares Alarcos, who is online, and he is from the Technical University of Catalonia. And please, Alberto, floor is yours. So you have 5 minutes. Try to speak quick. Yes.
Yeah.
Nice.
Hi, I'm sharing the screen. Can you see it?
Just a second. It's loading. Yeah. Yes. So the first one is full blue.
Yeah. That's intentional.
Thank you. Floor is yours.
Okay. Thanks. Well, thank you very much for the invitation. I'm sorry that I'm not there in person, but if in the next edition you are so kind to invite me again, then I will try. I will do my best to be there. And good morning, everyone. Just a brief introduction, just to give you a context of my talk. I'm a PhD student at the Institute of Robotica Informatica Industrial. So basically I work on cognitive robotics. And what I try to do is to see how knowledge representation can be useful in collaborative and adaptive applications in which robots interact with humans. But maybe the main reason why I'm here today is because I have been working with different groups from IEEE, in which we are trying to standardize ontologies for robotics. I have been the secretary of one of them that is already published, and I'm now the vice chair of a new group that have started this year. And just to give you some information about my institute, we have 4 different groups, but I belong to perception and manipulation. And well, basically we work on the formable objects because when you manipulate them, they change the shape, and that's really interesting. And also in applications where there are humans. This can be assistive robotics or collaborative robotics. And now is when the real talk starts. So as I said, I'm going to talk about ontologies for robotics and some efforts that have been done at the IEEE. And specifically, I don't know if you know, but IEEE is organized or divided into different societies. So everything that I'm going to say today belongs to the Robotics and Automation Society. IEEE has been doing standards from many years ago, but the Robot and Automation Society has started maybe 20 years ago or 15 years ago. So there are several standards that are already published. The first one was, the core ontology for robotics and automation. This was the first ever standard from the Robot and Automation Society, and it was published on 2015. And then there is another standard that is for the autonomous robotics ontology. I was the secretary of this group. And then there is a couple of standards more. One about how the representation of environments can be done in a map for robot navigation, and another one for ethically driven robots. But now there are 10 groups that are active. One about robot task representation, ontology reasoning for multiple robots. I'm the vice chair of that one. And then there are other ones like 3D map representation, which is a kind of extension of the previous one that we saw before. And there are also others about terminology for human-robot interaction, recommended practices for human-robot design subject studies, and so on. What I'm trying to give you here is the perspective that in this Robot and Automation Society from the IEEE group, we are not only developing standards on ontologies, but also on other things. And well, just to summarize, from all the ones that I just presented, the ones about the standards are these ones, just to have a clear idea. There are 3 that are already published, and you can access them. There is another one that probably is going to finish this year, the robot task and representation. And then the one that we just started, is going to be delivered at the end of 2026. And apart from that, those are the standards that are being developed by the Robot and Automation Society. But also we are doing some kind of efforts to promote harmonization and to try to extend the use of standards. And one example of them is there is a standards coordination or strategy meeting that is organized by Craig Slenoff from NIST, from USA. And the idea is to every year put together people in a room from different standardization organizations like IEEE, ISO, and so on, and see how the different works can be harmonized. So every year they meet, usually together with one of the major conferences in robotics, either IROS or ICRA. And this year I attended the one in ICRA in London. And well, as I said, the idea is to facilitate the collaboration between the different organizations, and also to identify if there is any kind of overlap between different standards, avoid those overlaps, but also to find new opportunities of collaboration or synergies between different standards. And as I said, there is always people from different organizations, ASME, ASTM, A3, OMG, and obviously IEEE and ISO. And another effort that we are doing is we are trying to organize different workshops on ontologies for robotics. Actually, Stefano Borgo is also organizing another one at one of the biggest conferences in robotics. But this one, I only put this one here because this one is not only about ontologies, but also ontology-based standards. And we have organized it twice. The first time was in Madrid during IROS, which is one of the biggest conferences for robotics. And then the last time was this year in London, so 2 weeks ago. You can check the websites to get more information. The idea here is to put together people from robotics, ontologies, and also standards. And then we spend the whole day discussing about how these three different domains can intervene together and be treated as a one domain, bigger domain. And I wonder if this is the end. Probably not, because there are a lot of things to do, a lot of ideas to share. And in order to finish the talk, I would like to invite you to, if you feel motivated to be part of these kind of efforts, especially the last ones that I presented. I can put you in contact with Craig Slenov if you want to join these meetings in which we try to harmonize the standards from ISO from different organizations, and also in the organization of the workshop, or even just as a participant or as a speaker. So thank you, and that's all.
Thanks a lot, Alberto.
Thank you.
Also for staying on time. So is there any question from the audience or online?
No questions online.
So for sure, I mean, so you mentioned ontologies and standards. So for sure, please, in the interactive part, don't forget to add references when we will ask for that chapter to point out the initiatives you have already mentioned now. So thank you again, Alberto. And I would like to invite Ilaria, who is also online. She couldn't join us in person, but so Ilaria Paponetti, she's from the University of Bologna. She's a very active from OntoCommons. Welcome, Ilaria. So floor is yours. You have 5 minutes, and please, would you like to share your screen? I think it's
yes, of course.
Otherwise, we have it here.
Okay, here. Yes. Okay, from the beginning. Okay. Just a second. Can you see my screen? Can you see my screen?
Yes, but only the last slide.
Okay. Okay. Sorry.
No worries. Now I think.
Okay.
So last one.
Okay.
Now we see the first
Perfect.
one. Thank you.
Okay. Hi everyone, I'm Ilaria Maria Paponetti from the University of Bologna. I'm a PhD student, and today I present how we can go from ISO to EMMO towards semantic interoperability for lifecycle assessment. So starting from a lifecycle use case that is a use case where semantic interoperability is fundamental, we consider a lifecycle of an utility car, and we can start from the functional unit where we have the customer requests and the environmental needs. Starting from defining the functional unit, the lifecycle of a product begins starting from design and passing through production, distribution, use, and waste. So we have the lifecycle phases composed by 5 main phases that correspond to different domains. So we imagine that we have to gather in data from a variety of heterogeneous sources in different lifecycle assessment phase for the lifecycle of only one product. So many fair questions arise: how many data, how many devices, people, location are involved and connected, where the product would be sold and how the car could be used. Lifecycle assessment has to manage all of these documentation, and as if it were not enough, lifecycle assessment is also composed by different phases, from goal and scope definition and ending to interpretation. Existing lifecycle assessment data formats only address syntactic interoperability. We have the interaction between all of these phases and exchanging data between them. But the last phase, the phase of interpretation, goes beyond syntactic interoperability to semantic interoperability, enabling meaningful comparison and analysis of environmental impacts. So this is an issue of semantic interoperability interdomains that in EMMO we call intradiscipline. So how to achieve semantic interoperability? Developing a formal standard that is based on the standards that are used. So reusing and improving existing efforts and knowledges. Ontologizing an ISO means taking the used terms in the real world, investigating to their meaning with an expert of the discipline, adding information to the ISO definition. Does not mean adding another resource to complicate the semantic interoperability. The general approach for lifecycle assessment ontology is to collect the terms from the ISO so we can know how users express themselves in the discipline, then sharing knowledge with domain expert, and at the end, after understanding what users actually mean with those terms, we create the ontology. Two main classes. The class on the left is LCA form entities that are about LCA object entities. But let's find out what is inside. LCA form entities were divided into complex form and elementary form, and also LCA data. Depending on the complexity of the concept they host. Then at the bottom of the figure, we can see all of LCA object entities from the processes in lifecycle, but also the entities and the quantities that enter and exit from and to the lifecycle. Here I want to focus on functional unit concept because it was difficult to interpret from the ISO definition that is also the lifecycle ontology elucidation, so quantified performance of a product system for a user for use as a reference unit. There is the implicit knowledge that is not shown in the ISO, and my ontology want to be explicit. Lifecycle assessment does not exist without functional unit that is a single data, and it is defined in the first phase of lifecycle assessment. At the bottom, we can see how a standard term can be represented in an ontology. Then the second point is align the lifecycle ontology developed. So align to an existing top-level ontology, EMMO, Elementary Multi-Perspective Material Ontology, and we focus on three of the perspectives, because any that are semiotics, holistic, and data. Any perspective adds information to standard definition without changing the general definition taken from the ISO. We create a strong hierarchical alignment. So LCA developed classes are subclasses of EMMO multi-perspective, and each entity can be subclass of different perspectives. As a conclusion, a lifecycle in ISO can be in EMMO also a workflow, but also a semiotic object. Thanks to the multi-perspective expressiveness, it is possible to enrich the existing standard and to use an improved standard, creating a formal standard knowledge framework. So I leave you with my message: learn from the ISO, use the ISO, and improve it. Thank you. Ilaria. Are you already?
Ilaria, we were clapping, but you didn't hear us because we are muted. So can you hear us, Ilaria?
Yes.
So sorry, yes. Thanks a lot. We were clapping here in the room, but yes, thank you. So thanks a lot to the audience. It's really nice. So thank you. Thank you for the nice presentation. And are there any questions to Ilaria, online or in person?
Nothing online.
No, so I would like to invite everybody. So thanks again, Ilaria, to please now become even more. There is a
Yeah.
hand. It's Amaya. Amaya, please. So can we invite Amaya to the stage? Thank you.
Yeah, I appreciate very much the presentation from Ilaria, and only to mention that we are involved in the IDIS project related with safe and sustainable by design, where life cycle assessment is one of the tools to, let's say, to proceed forward for the development of safe and sustainable by design materials. And we will be very happy to collaborate your studies. We have been mapping the life cycle assessment tools and methodologies and impact assessment of this. And yeah, I see that you are working in the ontology. Then we'll be a pleasure to collaborate together.
Yes, of course.
Thank you, Amaya. So we couldn't hear you very well, but yeah, I hope so. Amaya was talking about safe and sustainable by design and this activity. Yeah. So thank you. And then I would like to invite everybody to go to this website. We'll share it in a moment. So we are going to use a tool which is Mentimeter. I don't know if everybody is familiar with it. So we will ask you to use either your laptops or your phones to answer questions. Maybe if you're happy with that, we would like to ask you to come closer so that we can interact better for Michael, or you need to shout.
No, but people at home can hear.
They can hear well. Okay, so no problem. You can stay there. So and I would like to ask my colleague Arco to come here to moderate together this session. Is everybody here? So we would like to ask you in which role are you here today? So we know many of us have multiple hats. We would like to ask in which role are you here today? As an ontologist, database expert, application developer, end user, business developer, or other? Thank you. You should also answer. So we are, so Stein Erik, you would, Stein, why don't you? So please, everybody, take your phones or your laptops and go to this webpage and put this code so that you can participate in the live survey. The code is at the top. Maybe I can show it.
No, but it says please wait for the presenter.
Yeah. So, okay, so let's see. At the moment, we have 20 answers. So we have mostly ontologies, some end users. I'll just give a second for people to connect. If anybody is having issues, please ask on the chat for support. So we have a couple of questions to profile the audience, and then we go into real questions. So thank you. Then next one is again about profiling. So where does your institute or company sit on this map? So on the horizontal, you have the company size, and on the vertical, the percentage of public funding, where with public, we mean also competitive funding, like if you, for example, apply for Horizon projects and so on. So let's see. Yes, sometimes we have people that have lots of funding, really. And somebody with very, this we had also last time, somebody who is alone and with little funding. Why we ask you this is also to see how the uptake of technology correlates with the size of the company, that kind of funding.
What do you mean public funding?
Public lights is really from national, international. For example, Horizon would be public funding.
Okay.
Yeah, thank you. Just to give us an indication on which sources you rely. So, thank you. I need to be a bit quick because then we have the real questions afterwards. So then we would like to ask you, please, to say what are the main application domains of your company. So you can put 3 words. 3 words, and yeah, to give us an impression of the audience. expertise.
Doesn't really show the text.
Yeah, it's hidden not to influence the others. Yeah. Which in this case is fine, you shouldn't be influenced. But... So, yeah, not surprisingly, we have mostly manufacturing and sustainability, industry, higher education, ontology. Yes. Somehow, yeah, manufacturing is really the main one. So thank you. I still see some people are voting. We also have some adjacent topics. Thanks a lot. And even if I move to the next slide, you can still take time to answer, no worries. And then we would like to ask you about how is your data today? So this is to assess the situation, like what is the practice really? Your materials and manufacturing data at your institution today, is it open? So you have a slider, you can say how open, linked, fair, semantically enriched, human readable, human friendly, machine readable it is, and whether data stewardship is in place. So this, we try to assess different dimensions about maturity and uptake of FAIR principles and so on. When it comes to the materials and research and manufacturing data. So let's see the okay, so it seems in this audience the results are better than what we had last time. Of course, I mean, how quantitative can this be? But I mean, it's an assessment. So your data is documented on average in a way that is human friendly, but when it comes to machine readable and so on, there are more doubts. So there is, so nobody's really feeling confident to put a 5. So it means we are still not. But of course, I mean, it's just to give us an impression of how things are. And then, so thank you for this. I would like to ask you a very quick question. So in your institute or company, semantic technologies are heavily used, start to be used, are not used at all yet. And with use, so it's in a broad sense, but it is like, are you aware that in some department of your institution, they are used for data management or for software interoperability? So some use of ontologies is there in your institute, as far as you know, or not? Just to give us again a flavor of the uptake of technology. So let's see. Okay, so mostly they start to be used. Okay, thank you. Then we start with the real questions. Yes. Arko.
Yeah,
would
go
you
ahead.
like?
Go ahead.
Okay. So now I would like to ask you, as you heard before, we are trying to put together different classifications and so on. So about heterogeneity. So what types of heterogeneity do you mainly address in your everydays, either as problems or as solutions? For example, you have that use case or you develop solutions for that kind of heterogeneity. And we took them from Eusenat. So you have syntactic, which means different forms, terminological, so you have different names for same entities, conceptual or semantic, so you have different modeling of same domain. So for example, different perspectives, different conceptual models. or you have semiotic or pragmatic heterogeneity. So it means that the same entities are interpreted differently by different people. You might have all of the previous ones. And this helps us to understand what are the flavors that are more commonly, concerned.
So from this question, we would also like to have some discussion at the same time you are answering this. So please raise hand if you want to say something, but at the same time, maybe from this question or the later, I will ask some of you to give your opinion also.
Thank you. So we see, yeah, all of the previous is actually.
So this is a nice, outcome. It seems like the terminological is the highest, but it is very surprising to see there are some responses for the semiotic. And I would like to ask, I think I'm here. So I would like to ask, I don't know who answered, who responded into the semiotic, but can you give some example of the semiotic interoperability issue? Is there anybody who has responded to semiotic? Can you give some example of that? Yes, Martin.
One example of what we've meant by pragmatic interoperability in the past was that you specify roles. And one example for that many of you know is the role of the translator, for example, in the EMC.
Okay.
You also specify the process with the different steps of the translation.
Excellent, excellent. Yeah, that's a very good example. Yes, definitely. Yes, Maya.
We have problems in all these levels. We start for having problems in translating files, format files in different formats. Then we go to the problem about terminology, because they use distinct terminology for the same entity. Then they have, I work with petroleum domain, petroleum industry. So I have the problem about that over the same domain, I have reservoir engineers and geologists and production engineering that analyze and give different, to the same entity, different meanings and attach with different qualifiers and so on. So I have this problem about semiotic. And you can choose. And I have the problem about database integration and searching. It's a lot of fun to get from it.
Excellent.
Thank you. Thank you.
Ontology only mean ontology only mean different things to different people.
Oh, it's quite open. We are not actually specifying whether it is.
No, that's what I'm saying. It's a semiotic problem also, because people interpret ontologies in different ways.
Very true. Very true. Yes.
Very true. But then we are kind of going in a very broad definition.
No, but you're right. Yeah, the very same terms we are using. For example, that's why interoperability itself, people mean different things, right? So thank you, everyone. So
yes,
now
we'll go to the next.
We would like to ask you. So these are some aspects, but then we would like to ask you, as was already mentioned, what kind of systems do you make more interoperable, so to speak? So do you consider data sets, databases, as was already mentioned, software, things, humans, communities, ontologies, or other? If you have any doubts about what we mean, just please ask us.
Yes, I don't understand.
Please. So with data sets, we mean, for example, files, single files. With databases, like.
No, I don't understand.
The question. So imagine in your use case, when it's about interoperability, which kind of things are you make? So interoperability is like operate together. So something to work together. Which things are you trying to make work together?
So we are taking this word interoperability in the kind of like a dictionary meaning. So if you say like in my organization, people are not working with each other. So that's also an interoperability problem. So
can you make a data set interoperable with humans?
Also, so in that case, yes, I understand. Yes, you can click multiple ones. Yes,
yeah, you can click multiple. Yeah.
Yes. There was a raised hand. Thank you. Okay.
Amaya, you can unmute your microphone if you want to speak.
Maybe it's the previous raised hand. Could be an old relic raised hand. Or it's a new one.
No, I think it's new.
New. Okay.
Previous one, I didn't raise the hand.
Okay. No worries. No worries. So maybe we can show the results. Yes. Let's see. So we have quite a cake here. So yeah, it's quite split. So it looks like we didn't miss too many things because other is more, which is good. It's always good when other is not a 90%. And
so most importantly is that, of course, we are all aware of this databases, software to be interoperable, but then the things, of course, Internet of Things are actually trying to do that, but now humans, communities are kind of very futuristic, I believe, but then you can say, no, this is a very much pertinent problem. So any opinion on that, like, or probably, yes, this one?
So I think this picture is syntactically inefficient. So the question is what kinds of systems? Data sets is not a kind of system. Databases is not a kind of system. Things is not a kind of system. Humans is not a kind of system. So you would be well advised to use singular nouns, which, when added to the word system, create the name of the type of system.
That's correct.
And you get maybe 7 out of 10 choices.
Yeah, so it's probably better to be understood as a
units,
the member of those corresponding systems. So if you say human, maybe we mean the society or the community in general, kind of.
Then say that.
Maybe we should have said units. Which kind of units? Maybe would have been better. No.
I think that interoperability in general applies most readily to systems. Yes. Information systems, communities of scientists working in a given area, they form a system. Software systems, maybe ontology systems, but in any case, that's what gets interoperable.
Yeah.
One ontology is not interoperable with another ontology in the normal use of the word interoperable.
So let's say within that system, you make the units more interoperable. This would be more...
Something like that.
Yeah.
Thank you. Thank you.
And also between systems. So the standard is, how do I make this information system interoperable with that information system?
Yes, as Stefano was saying.
That's the paradigm.
Yes, yes. Yeah. Thank you. Thank you. So we can move to the next one. So here we ask you how important are these dimensions when assessing interoperability solutions like methods and tools. So what we are trying to do here is to find dimensions that are important to characterize solutions. So we put some, and then we will ask you if you have others. So one is logical expressivity, precision of agreement, computational complexity, ease of integration with legacy tools or workflows, and use of standards.
So just to specify a couple of points. So solution, as you can see, we mean both method and tools. And when we say dimensions, so for each of these dimensions, there can be multiple metrics possible. So of course, we are not really we are not trying to know which are the measurement, but we are trying to know what are the dimension you are mostly interested in terms of interoperability.
Yeah, so imagine we have two different solutions. We would like to be able to compare them in some direction, right? Please, Stefano.
It's kind of like very significant.
Is between the people that decide to use the solution?
No, sorry. So that's okay. Okay, sure. So there we mean, for example, when you have a solution, is the solution able to express very precise agreement or not? So imagine we are in the medical domain. We need to be able to be very precise about our statements. So do we want a solution who is able to be very precise, or we need a solution? We don't care much about precision. We care more about getting an answer. So it's like about the capability of the solution to assess the precision of agreement. I hope this is clear.
So say, for example, like the discussion we were having yesterday, whether doing first order logic axiom is like, of course, that will be the logical expressivity, precision are really high, but also the computational complexity will be high. So, in your opinion, you will say, okay, even if the computational complexity is high, we should have the logical expressivity and precision of agreement as the most important thing. I do not care about computation.
Please, Mark.
I think the problem is with the word agreement. Yeah, what agreement?
Where is it?
Precision of agreement. What do you mean by agreement?
Agreement between the community. So, if this interoperability solution can be understood and agreeable to everybody. Like, I mean, say, so the same example, if I write a first order logic axiom, it will be very much precise to be agreed by everybody. But if I write it in a natural language, people may not has some ambiguity in their mind.
When we wrote Deutsche Code, the point was exactly this one. We wrote actions that everybody can read according to their philosophy and still agree that is a correct statement. So it's not really logic.
No, so the question is not that. The question is that, do you think that agreement is really required or not?
I mean,
you may feel that agreement it's not so important.
I think we should agree, we should move on.
It's better not to go into this.
Just in the interest of time, and also that this question maybe wasn't very precise. But we can see what people... So it looks like the ease of integration with legacy tools is the most important dimension, but it seems like all were considered relevant. But we would like to ask for your input, like, what other dimensions are important when assessing the solution? So for example, if I want to, where we are writing a review of solutions, what are the dimensions we should consider as most important? For example, yesterday in Stefano's talk, there was a dimension which was parsimony. So this kind of dimensions, which dimensions, in your opinion, are important? And then second question, of course, in the future is like, how do we actually measure it? But
I mean, our goal is to figure that out. I do not think there is a robust methodology for evaluating interoperability between system, between data, or even ontology, I don't know. But then, so, I mean, there are many different methods people are proposing. So if you know some or you have proposed anything, please mention. And actually, this will go into the review of domain interoperability deliverable of us.
Yes, so thank you for your inputs, because they are really valuable. There is a real hand or...
Yeah, I mean, there was a new raised hand again from Amaya, but I don't know if it was...
Amaya, in case you have any...
No.
Okay.
No, it's not. Okay.
Did you all see it appear, right? It wasn't just me.
No worries.
There it is.
Amaya, there is a really raising hand. No worries. Just we know that it's not intentional, but yeah, there is an unintentional hand. No worries. Sorry. So we can start sharing the results. So I'm sorry we are delaying lunch. I hope you are...
Yeah. As soon as you can answer.
You will get some lunch at some point.
We'll let you have.
So thanks a lot. So parsimony, I hope I didn't influence the audience. Then we have precision, Can I scroll? Yes, enter to stop scroll.
Yeah, the scalability is really important. Yeah, ease of uptake. Yeah.
Sorry, mouse. Okay, yes, now it's functioning. I just wanted to scroll across the solutions. So it is important that interoperability standards are final and not changing. Yes, so for example, you have versioning stability. We could have something like this. Yes, scalability, generality.
So just to clarify, Stefano, that when you said parsimony, but in terms of interoperability, it is not the parsimony of the predicates, right? It is the parsimony probably between the links, like how many less link we can have to express the entire interoperability. Is that right?
Yeah, in my list there was also relations, so it is the link. So
okay.
But of course, I was talking about something different.
Yeah. It's not the type of relation. You were talking about type of relation, but here is the number of relations.
Yeah, I just mentioned it like a possible dimension, like economy in language. Now it's called sometimes. And we have few answers in the direction of ease of use and documentation and barriers to adoption. So thanks a lot. Please.
I think you need to still. I mean, I like your presentation. That definitely. I'm interested in hearing more about your presentation. A lot of these questions also, I think you have to kind of divide it into like, functional and non-functional kind of categories. Because when you say interoperability is very functional, kind of associated with that.
Yes. No, actually, so we had to formulate the questions in a way that was answerable in a finite time and allow people for lunch. But yeah, of course, you are very right. Yeah, thank you, sir. Yeah, there are many nuances here in principle, but so let's move on. So here it's about the technical components, building blocks. So we are thinking about somebody developing, imagine a platform or a database. So what are the most crucial components for interoperability? And we'll ask you to please rank these ones. And then afterwards, we will ask you if there are others that you think are missing here.
And I hope that all the answer goes to ontology and everything else is zero.
So we identified they are in alphabetical order. So you have crosswalks, data models and formats, data exchange APIs, data provenance and traceability functions, format converters, mappings, ontologies, standards including languages. And some of these, as you can recognize, they come from the Data Spaces Support Center project.
So please don't be influenced by me. You can say that ontology doesn't help in interoperability.
What is the crosswalk?
Crosswalks are like a combination of mappings. So it's a crosswalk across different, say, data models. So you have one data model, and then you go from one to the second, and to the second to the third. It's like a walk.
Yes, sir.
So I would like to make precisely that point that ontologies do not help in interoperability because most ontologies are bad.
And also not interoperable with each other.
Exactly. Yeah. A small set of really well-tailored, expert-controlled, interoperable ontologies if ontology is going to help interoperability. Otherwise, it just adds an extra.
Yeah, that's a caveat. We should write it in a bracket, like, yes. That's like, yeah, for sure.
And I would add as number 9, money.
Not sure it's a technical component, but you can add it in the next slide. There is this opportunity. But so we need to go ahead, otherwise we don't get lunch, and I think then we will be unhappy. So this is about what other technical components besides money are crucial for interoperability.
We didn't show the results.
Oh, sorry.
Yeah, so you can answer that.
Sorry, I didn't show the results. Apologies. We were too eager to get lunch. So the first one was data models and formats. I hope me going back doesn't cause interference. Ontologies is there, and data exchange APIs, standards mapping. So the last one is crossworks, which maybe is just using a sub-community. But data models, thank you, sorry for this. So here is, are there any other components that are crucial? We are thinking at the level of an architecture, high-level architecture design.
Yeah.
So what types of components should one have in the design?
Say, for example, I mean, we didn't mention, but then RAMI is a very well-known interoperability framework in manufacturing. But then it's similar, you can mention.
So imagine here we are trying to help somebody who is going to develop a platform and would like to include semantic technologies, but maybe it's not their domain. So what are the components that are crucial?
Okay.
So we can start seeing willingness. I'm not sure it's a technical component, but commitment. Okay, they are non-technical.
Yeah, that was me.
That was you.
I think it's a technical component.
Okay. Simplicity. So these are, they are, I would say, other, but okay. Meaningful data must be present. Yes, this is like a precondition. Well-developed GUIs for ontology extend. Very nice. Yes. So GUIs for interaction with humans.
Very nice. Yeah.
Yes. Thank you. Community involvement. Yeah. So somehow this, I would say, many of them are not technical, but we understand they are crucial aspects. Yeah. Tools. So we need to speed up a bit, but please, afterwards, you are very welcome to just come to us and tell us your input.
Yeah.
So here it's about measuring things, actually. So interoperability metrics. What metrics or tools do you actually use to assess or quantify the maturity or the interoperability of your data? So we are aware there are some solutions, and there are some methods that quantify interoperability. For example, okay, I don't want to influence you. I'll tell you later. But we would like to know if you use any of this or are aware of any of this.
I mean, the questions are getting even more harder now because it's like very few tools. And then this is a real question we have, like what are the tools available?
Yeah, we are trying. I'm sorry, we are a bit rushed, but due to lack of interoperability this morning. So, oops and foops, fair metrics.
Yes.
Number of users is okay.
Yeah, the fair evaluation tools are the only thing I can remember for the interoperability because they have something that. But it is also true that the fairness is about one item of it, and it measures its capability to be interoperable. But then it does not measure interoperability of a solution or a system, as Barry was mentioning. That this is our notion. And
but I like that we have like end user satisfaction as a, which indeed, is also an indicator.
Okay, thank you. I'm going to go to the next.
Yes, going to the next. So what principles, recommendations would you point out, like papers or initiatives?
Initiatives. Good place to talk about your publication.
But for example, you can put an acronym of an initiative, if it's DOI of a paper, or afterwards you can send us if this is not. Because there are multiple initiatives. We are aware of some, but there are multiple initiatives. And there are in the literature sets of principles. I think we are all very hungry. But we can show the results. The AI fair principle, yes. CWISO send workshop agreements of ModGraph, which is for the topological representation of processes, epistemic metadata, industrial data ontology. Be aware about standards. Okay. RDA, thank you. Yes, so here we are really after initiatives with, yeah, like, I don't know, EMMC, just name one, but institutions or associations. So here is a hard one, so maybe this is for discussion.
I mean, she already asked for everybody to be present at 1:55, but then she's saying it's okay to get it done.
Yeah. Okay. So we close.
No, I mean, it's okay. You can take a little bit more time.
So we would like to ask you how to facilitate cross-domain interoperability. So this is an open question.
Yeah, we are getting late for the lunch, but then if you agree, like, I mean, and want to say few words, if you feel like that, really, I mean, the question is, of course, probably very understandable that we are talking about it for the whole session, that ontology is probably the mean. But if you think, if you have some comment on that, maybe.
Yeah, really about the cross-domain aspect of it. Because,
what do you mean by domain? Give example.
So, for example, if you want to have, say, biology data to interact with I don't know, with chemistry data.
Biopharma is a very good example where biology needs to talk to manufacturing, right?
You're talking about also like a banking.
Yeah, banking, finance needs to talk. Yeah, but then it's not that okay, we all kind of like convinced probably that ontology will solve all the problem, but if you really think it differently, then we'd like to know.
Good ontology.
Good ontology, yes.
Yeah, because for example, so if you have different domains, should you have a framework where the domains are identified and people can and plug in their subdomains, or I mean something like this? I mean, like a centralized framework, or I also don't want to influence you too much.
Ontology built using at least a top level ontology to be.
Yes, that would be answer.
Yeah.
So alignment, we see,
yeah,
bringing people together. So it's like, yeah, not non-technical part, using standards, top level ontologies as a solution. So we heard this is documentation.
Yeah, we got
communication.
A lot of input,
yeah, thanks a lot.
Good. Yes.
Thank you. So ontologies and standards, we already heard about this multiple times. So here, 3 quick questions. What's your opinion about these statements on ontologies and standards in the sense of ISO? So do you agree or disagree? We should ontologize standards. We should standardize ontologies. Or standards and ontologies are different solutions. There is no need or benefit in merging these approaches.
Where merging is one of the 2 previous, or is something different also?
Say again?
One of the 2, like standard and ontology. Yeah.
So I didn't get the question.
No, because you can merge them in different ways. You are referring to the first and second.
No, I'm referring to standard and ontologies.
Yeah, but the merging.
Yes.
It's about ontologize standards or standardize ontology.
Exactly. For example, or other approaches. Yes. Yes.
No, he wants to say that, are we talking about this process to be merged or ontology and standard to be merged? Whether the
I'm lost.
earlier process to be marked.
I'm lost.
So
there is some redundancy. The third question is a bit redundant with the first two, is to cross-check.
No, I think the question, I mean, the thing is that ontology and standard, and there are two different communities, let's say. Do we need to really bring them together, or let them do their own thing at their own? I mean, we do not need to merge them.
So standards in the sense of ISO, because one could also say. Because we heard the different opinions, right? Some people said no, it's not good. We should or we shouldn't. So let's see. So it seems the answers are consistent. So it's like, yeah, we should ontologize standards and standardized ontologies. So there is a benefit actually.
That's a very
bringing
perfect
together.
answer.
Thank you. Thank you. So the final questions. So we have questions about the role of AI. So what role can large language models have for interoperability today? So do you think they can replace ontologies, can help to acquire knowledge, help to create lists of terms, help in creating taxonomies, help in identifying relationships between terms?
So large language model, by large language model, as you know, we are talking about this recent hype of ChatGPT and all sort of GPTs. And they are being, touted by some of the experts in the AI field to be obsoleting a lot of technologies. And there are some talk that that ontologies are no longer needed because they can be learned from the large language model. It will be great to know your opinion. Actually, I think Barry will have some opinion on this for sure. I actually know his opinion, but still, like, what do you think?
So it stopped accepting my proposals, your system. It must be prejudiced.
So let's see.
Okay.
I stand over there.
Yes, Chris.
We're doing an asynchronous interoperability from a large asset management system, from one system to another, from a side-office system you might not have heard of to Aviva, which is a system, if you're an engineer, you might have heard of. We're actually using a lot of ChatGPT for the lower level stuff, and we're finding it's useful. However, it's the moment the current way it's working, it's incomprehensible. We think we'll be able to use it to get the soup to nuts interoperable. It's just like it's trying to use a teaspoon to empty the Mediterranean. I don't know. It's just they're so incompatible. It's just inconceivable that you'll be able to do it. I mean, I'm not saying I don't know.
In future,
criteria you need. It's just inconceivable.
So the problem is that there is almost certainly a lot of ontology-related content on the internet, which is being trolled by the large language models. That content is mostly bad because most ontologies are bad. But in any case, it's a massive inconsistency. And so if you mine that without any controls, you'll end up with a massive inconsistency. You'll just make your life harder. In order to solve the problem, you would need to have a suite of well-developed, good ontologies, which would serve as a control to what kind of output from a large language model you accept. To build that is incredibly hard. And it doesn't scale. We don't have enough people.
Exactly.
And
ChatGPT also makes up stuff.
Yeah, so I will take Florina first, and then I'll take Florina and then Francisca.
I think to answer this question, you really need to understand what a language model is. Because from all the list here, you actually say AI. Language models are not really AI.
This is also for space reasons.
Okay. Basically, none of that. Actually, I would answer with no to almost all of them.
Yeah, please, what is your
because the language models, if you understand how they are trained, they are not doing any kind of analysis. They are just predicting something which they see. Yeah, they don't help you. There are tools which can analyze a text, and then give you back relationships between terms and everything. And those are not language models. Yeah, those are really different type of AI systems that look at text and analyze the type of words. They can do a lot of stuff. Language models, no, definitely no. You can use neural networks. Language models also use neural network technology, but you can use neural network technology for classifying your terms in a text, for example. Yeah, and then another very important thing here is what do you give as input to these models? Because if you give it an ontology, you know, the RDF file or something, that language model won't know what to do with it. Yeah, with just embed things. Yeah, so you really need to define your problem very well, because if I give you a technical text, my neural net model would probably detect very well the terms, the technical terms inside, but it would not detect the relationships between them. I know about this because my very close collaborator of mine does exactly this kind of stuff. I'm trying to identify if this technical term is an instance of this other group of technical terms, or is it in the same category and so on, and it's not trivial. So she's a linguist, yeah, so she's working with this.
So if I summarize what you are saying is that, okay, it is right now in the current state, it is not meant to do anything with the interoperability ontology, but if we build them for that purpose, which
not
is kind of,
models,
not even
other AI tools,
but
not
thank
language
you.
models.
Yeah. Thanks a lot for it.
Yes.
But I think at least we have been trying out with Margaret to just it can help trying to document the data, make your data models, and get to the question of capability being interoperable by helping out making predictions that then someone has to validate.
So yeah,
we have been trying out and fairly successfully.
Okay.
Just more.
Somebody want to?
No. I definitely can suggest something, but at some point you need someone, but it does make things up. And,
it's hallucinatory, kind of.
Yes. I'm surprised.
Chris wanted to say something in the end. I don't know if he wanted to make a comment. Chris? Okay.
But I'm surprised that you also think it's so that he can help in identifying relations, which is not trivial.
Okay.
And this maybe we can discuss. We can discuss later. And similarly, these two questions really for lunch is like how best to combine. We heard something already from Florina, is like one should distinguish between which tools you are using, what you want to do with them. So we need to be more precise. And the other question was like, is there anything we missed? But then with this, we thank you and ask you to, I mean, we give you lunch.
We don't give you lunch, don't the lunch will be there. And
but we thank you a lot, really. But we would like, I mean, if there is anything we missed, just come to us and tell us. We are very happy. I mean, we really welcome your input. Thanks a lot.